Hello GATE aspirants, welcome to part 5 of GATE solid state physics series. Question number 19. The Miller indices of a plane passing through the 3 points having coordinates 0, 0, 1, 1, 0, 0, 1 by 2, 1 by 2, 1 by 4 are. So first of all, let us find out equation of plane, and the formula for this is like this. So consider a determinant x minus x1, y minus y1, z minus z1. Here x2 minus x1. So this coordinate will be x1. So let me write here. x1 is 0, 0, 1. x2 will be this 1, 0, 0. So this will be x1, y1, z1, and this will be x2, y2, z2, and this will be x3, y3, and z3. So next will be here y2 minus y1 and z2 minus z1. Next will be x3 minus x1, then y3 minus y1 and z3 minus z1. And this should be equal to 0. That will give you equation of plane. So x minus x1 is 0, then y minus 0, then z minus 1. Next 1 minus 0 is 1, then we have 0 minus 1, half, half, minus 3 by 2, and this will be equal to 0. So we can solve this determinant. So this will be x into 0 minus minus 1 by 2, that will be 1 by 2. Next is minus y, in bracket it will be minus 3 by 4, minus minus plus 1 by 2, plus z minus 1 into 1 by 2 is equal to 0. So this will be x by 2 minus, this will be 1 by 4. So this will be minus minus plus. So 1 by 4 into y plus z by 2 minus 1 by 2 is equal to 0. Now make the denominator 1. So this will be 2x plus y plus 2z is equal to 2. And this we can compare with hx plus ky plus lz, and that is equal to 2. So that is some constant. So let me write some constant here. So by comparison we will get HKL is equal to 212. So option A is correct. Also, if we want to find out intercepts, then we can say that this is z intercept. So this will be z intercept will be 1. So z will be 1, and x intercept here it is connected at 1. So 1, 0, 0. That means x intercept is equal to 1. Similarly, if we put this coordinates in this equation, this is the equation that we are getting, right? So if I put x is equal to 0 and z is equal to 0, then I will get y is equal to 2. So then the method is to take reciprocals of these numbers. So this will be 1 by 1, 1 by 2, and 1 by 1, and then take LCM of this. So that will be 212. So by both methods we will get 210, but the answer to this question in the answer key was given option C, but I am getting 212. Next, question number 20. The plot of specific heat versus temperature across the superconducting transition temperature is most appropriately represented by. So there will be some disrupt value at Tc. So option A is correct. So this is variation of specific heat versus temperature. Option A. Next, question number 22. The energy Ek for band electrons as a function of the wave vector k in the first Brillouin zone minus pi by a to pi by a of a one-dimensional monoatomic lattice is shown. The variation of group velocity is most appropriately represented by. So if we have one-dimensional monoatomic lattice, then for that E is equal to E naught minus gamma beta cos Ka. Now, if you want to find variation of group velocity, then Vk is equal to, it will be equal to 1 upon h cross dE by dk. that is d omega by dk. So this will be 1 upon h cross a from here cos ka, and then it will be gamma b, and derivative of cos is minus sign. So this minus sign will be taken care of and into sin ke. So it is a sine function, so you will get a sine function. Also Vg will be 0 at 0 and at plus minus pi by a when k's values is this. So it will be a sine function. So we are getting sine function in option B. So option B is correct. Also it is satisfying that k is when k is 0 and when k is plus minus pi by a, then value of Vg will be 0. Next question. For a free electron gas in 2 dimension, the variation of density of states as a function of energy is best described by. Now, density of states GEDK, first we will consider this in 2D. So, GK dk in 2D is like this, L upon 2 pi whole square into 2 pi k dk. Let us convert this into GEDE. Now we have k is equal to under root twice me upon h cut square. So from here dk will be under root twice m h cut square, that is a constant, and root e is equal to 1 upon 2 root e into d. So we can substitute this in this equation. So we will get GE dE is equal to, so this will be L square by 4 pi square into 2 pi into value of k is under root twice me upon h cut square into dk, and that is twice m upon h cut square upon 1 by 2 root e into de. Now here we also have to consider spin digits. So electron is a half spin particle, so for that purpose we have to multiply by 2 as well. So this 2 and 2 will cancel out, this root t will cancel out, and this 2 pi and 2 pi will cancel out. So this will be L square by 2 pi into twice m by h cut square into de. Now density of states is simply GED by E. So here there is no E term. That means this NE dE, it will be proportional to e raised to 0. So it will be a constant. So option C is correct. It will be a constant function. Next question. For nickel, the number of density is 8 into 10 raised to 23 atoms per centimeter cube, and electron configuration is given. The value of the saturation magnetization of nickel in its ferromagnetic state is. Now saturation magnetization is the maximum value of magnetization. That is when all the magnetic dipoles of an atom are aligned towards the field. So that will be the maximum value, and this is given by this ms, that is saturation magnetization, is equal to number of Bohr magneton into Bohr magneton. This will be per atom, number of Bohr magneton per atom into Bohr magneton into number density. So number of Bohr magneton per atom for nickel is 0.6 into mu b, that will be Bohr magneton, into n, that is number density. So this will be 0.6 into value of mu b is given 9.21 into 10 to the power minus 21 ampere meter square into number density is 8 into 10 raised to 23, but it is atoms per centimeter cube. So we have to convert it per meter cube. So into 10 raised to 6. This comes out to be 44.208 into 10 raised to 8, or we can write this as 4.4208 into 10 to the power 9. So this will be the answer, and the answer given to this question was this range given was 40 to 43, but the answer is not matching here. Maybe some decimal point shifting there is there. So I am getting 4.42 here. Next question. Neutrons moving with speed 10 raised to 3 meter per second are used for the determination of crystal structure if the Bragg's angle for the first order diffraction is 30 degree and the intermolar spacing of the crystal is. So we have this formula, Bragg's law, that is 2d sine theta is equal to n into lambda. Also we know that lambda is equal to h by p, or we can write this as n into h by m into v. So this will be 2 into d into sine 30 degree, n is 1 into h upon m into v. So sine 30 is 1 by 2 and 2 will cancel out. So d is equal to this. Now h is equal to 6.63 into 10 raised to minus 34 upon m is 1.675 into 10 to the power minus 27 into 10 to the power 3. And this comes out to be 3.95 into 10 raised to minus 10 meter. So that will be 3.95 angstrom. So this is the answer, and the range for this question is 9.31 to 4.15, and we are getting 3.95. So these were all the questions from 2014 paper. If you like this video, please give it thumbs up and subscribe to my channel for more videos. Keep learning.